There are many ways to solving this problem. I can say you can redraw this problem in a few different ways, but let me show you my way. Okay, so I'm going to call this point, this one my point A. This is my point B. Okay, so this point B is also this point, right? So if I'm going to draw something like this, so we have A, point A, right? And this is my resistor R4 over here. And I have my resistor R3 over here. I have my resistor over here R5. Point A is connected with resistor R2. Okay, this is my resistor R2, and the other side of R2 is connected with point B, and this is my, by the way, this is my point B. Okay, and point B is also connected to resistor R1, and I have over here my ohm meter. Okay, let's check if this is true. We have ohm meter connected to R1. Okay, we have R1. R1 is connected to R2. So R1 is connected to R2. R1 is also connected to point B. R1 is also connected to point B, to resistor R3 and R5. So we can say that these two circuits are the same. They the same, but this one, in my opinion, looks much simpler. You can see that these two resistors are in parallel. Okay, so I can find the total resistance of resistor R23. So I have R23 is equal R2 times R3 over R2 plus R3. This is the product over the sum. So I have R2 is 4.2K times 4.2K over, open parenthesis, 4.2K plus 4.2K. Because these two resistors are in parallel and they have the same resistance, the total resistance of this connection is going to be simply half of the resistance at these two resistors. So we have 2.1 kilo ohms. Okay, because we can use product over the sum, or we can also use the formula R total is equal R over N, which is basically is going to give me the same answer. Next, I can redraw the circuit. So my circuit right now is going to look like this. This is R2, 3, and this is my R4, this is my ground, and this is my R5, okay, and this is my resistor R1, and this is of course my ohm meter over here. Next, please realize that this time we have ohm meter on the right side, so that's why I have to start solving this problem from the left side. Now these two resistors are in series, so what I'm going to find, I'm going to find the total resistance for these two. So R2, 3, I'm supposed to say equivalent resistance for these two. 4 is equal R2, 3 plus R4. R2, 3 is equal 2.1 kilo ohms plus R4, which is equal 6 kilo ohms. So R2, 3, 4 is equal, this is 8.1 kilo ohms. Okay, so this is my total resistance of these two resistors. Next, I can redraw the circuit again, and I'm going to simply have resistance R2, 3, 4, and I have resistor R5, and I have resistance R1. This is my ohmmeter, by the way. Okay, this is my ohmmeter. So these two resistors are in parallel. Okay, R2, 3, 4 and R5, they are in parallel. So that's why I'm going to find the equivalent resistance of R2, 3, 4, 5 is equal to R2, 3, 4 times R5 over R2, 3, 4 plus R5. So R2, 3, 4, 5 is equal 8.1 kilo ohms times R5, which is equal 3.9 kilo ohms over 8.1 kilo ohms plus 3.9 kilo ohms. So R2, 3, 4, 5 is equal 8.1 exponent 3 times 3.9 exponent 3 equals, divided by open parenthesis 8.1 exponent 3 plus 3.9 exponent 3 close parenthesis equals 2.63 kilo ohms. Okay, so this is the equivalent resistance for these two resistors. Now we can redraw the circuit again and simply draw resistor R2, 3, 4, 5 and my resistor R1, and this is my ohmmeter. So R total is equal R1 plus R2, 3, 4, 5. So R total is equal, R1 is equal 2.2 kilo ohms plus R2, 3, 4, 5, 2.63 kilo ohms. So R total is equal 4.83 kilo ohms. Okay, and this is simply the solution to my problem.